Hello, and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video on Math Bits, of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom, especially today when the Braves have made it to the World Series for the first time since 1999. Yo, it's been a minute since they've been there. Last time they got trounced by the Yankees. This time, let's take on the cheating Astros. Game 1. But let's do some math instead. So, in wrapping up our polynomial run, as we've done factoring of quadratics and cubics and quartics and higher power things, we'll continue with it, and we're even going to do some factoring as well. But today we're going to do it where we divide polynomials using long division and synthetic division, both of them. And I got 12 practice problems for you. 6 where we're going to do long division, 6 where we're going to use synthetic division, and just jump right into it. Now, if something's non-factorable, not non-factorable, if you don't know how to factor something, but you do know a factor of it, let's divide that factor out and see what else we can factor down. And that's my goal when I crafted this worksheet. I wanted to get a lot of things that could factor down alongside what it is that already exists as a factor. And that's what we're going to do with it. Now, some caveats with this. Number one, because this isn't a lecture of sorts, it is a practice problems thing. This one's a little bit hard to give you a little teaching beforehand. I really feel like I can't show you how to do it unless I kind of just do it. And I know there are different problems that run into different things, but you'll see that the format kind of gets the same. And that's my hope, that you can get really comfortable and familiar with the format. But number two, what's also important is, especially for long division, is that you've probably done long division in the past, and if so, you probably had a certain style with it. So I hope you know something about long division, about a way that you've done it before, and I hope you're kind of comfortable with that thing, because if you haven't done long division before, this will look really weird. Okay, synthetic division will look weird because it'll be different, but at least you've done long division along with it. Synthetic division is clean enough that I'm sure you can pick it up after doing long division and just kind of tie them in, but I hope you've done long division in the past. That being said, everyone has a specific style with long division, as do I. I have my own habits and routines. Some of them are probably a little ill-kempt. Like, there are some things like I don't put a subtraction symbol probably where I should. That's really one of the big things I want to talk about. So I apologize if what I do doesn't quite look normal with what you do, and I'm not asking you to pick up my habits, but what we do in long division itself is quite the thing. And I know I'm going on like this 3-minute spiel about all this stuff, but I just want to make sure that you really know what it is that I'm doing with it, so you can give your own style, its own way, and run it in tandem with mine if you're trying it with me. Okay, so it's just a nice little important thing. I'll speak out loud what's going on every step of the way. So I do want to get straight into it, guys, as you look at a black screen. There we go. Dividing polynomials. So we're going to divide using long division on the front page, these 6 problems here. Now, and we're going to write the result in factored form. So what this means here, guys, what we're actually looking at, if you will indulge me, is that we're really looking at this expression right here, 10n squared minus 46n plus 24. This is, to me, this is the OG expression in and of itself. It is the dividend. And I'm going to provide you a divisor. I'm going to provide you something that actually factors out from here. Now, just as a caveat, this is a quadratic, and if this does factor out, I guess that means this is factorable. So we could learn how to factor that thing as well, but we're practicing the division only with this. The point I want to make, though, is that as we divide this polynomial by this factor right here, we're going to end up with some other result. What I'm going to do is I'm going to end up writing how this thing is written in factored form with this times whatever the quotient is. Right? If the dividend divided by the divisor is the quotient, then the divisor times the quotient also equals the dividend. That being said, when we write that in factored form, sometimes the quotient is also going to be factorable. In fact, I believe that I tried to make sure that this was almost always factorable in those instances. Sorry for spending so long on this. We will go ahead, I think, and get started after I mention that. Let me think if there's anything else I wanted to say. Suddenly I felt like there was something. Now I don't know. All right, let's get started here on number 1. Number 1, we have 10n squared minus 46n plus 24 divided by n minus 4. So I'm going to write out 10n squared minus 46n plus 24. And in long division, the dividend goes here, and the divisor kind of goes out like that. And what we're going to do is divide this by this, and we're going to end up with the result that I'm going to write on top as the quotient. So here's what we do. We are going to only look at this n, the leading term in the divisor, if this was in standard form, and we are going to see how many times n can go into the leading term that is in the dividend right here. So how many times does n go into 10n squared? Really what I'm asking you is n times what equals 10n squared. And this is how we're going to be doing this long division. That's one of those things where I'm telling you that's how it's done. And hopefully you can kind of just make sense of that. So n times 10n would give you 10n squared. And now what we're going to do, as you would do with long division, is you take this and multiply by 10n, and then you subtract that out from this result. So I'm going to do n times 10n, which is 10n squared, and negative 4 times 10n, which is negative 40n. And we're going to subtract this result here. Now, I say subtract, but I don't write it. And this is one of the little things that I think get people kind of upset. It's something that I do, and I don't know how to get around it. I'm not going to change my own habits, sorry. But I'm going to subtract this entire, I'm showing you right now, this is what we are doing. I'm going to subtract this result here, which really means we're subtracting 10n squared and we're adding 40n. So ultimately, guys, this is what's happening. It just won't be marked. I'm saying I could just mark it right there. I just won't. You can't change someone's nature. 10n squared minus 10n squared is 0. And this is what you're anticipating to have. We are going to lower each degree. We went from a quadratic here, then we're going to deal with the linear terms, whatever exists, and then constants if we can. Which we won't be able to with an n unless there's... Oh, that's the last thing I wanted to state. All of these things will have a 0 remainder. Now, that's not something that's normally expected of long division with polynomials. You generally expect to have remainders here and there. It's just the nature of things. But since I'm so focused on having my students factor right now, just practice factoring and factoring over and again, and since really this is just getting your feet wet for division in general, I'm just going to go without the remainder to start with, and I hope that's okay. Maybe in a future date if we talk about some more things. It's really, you can save it for pre-calc. You can save remainder stuff for pre-calc. It's totally fine. Get used to this format. Anyway, 10n squared minus 10n squared is 0. That one's gone. Negative 46 and minus negative 40n is negative 46n plus 40n, and that is negative 6n. No, I did not write the plus there. I subtracted a negative, though. And 24 minus 0 is 24. So we bring down the 24 there, and we are going to repeat this process. And I tend to do this as well. I like to put this right here and say, hey, how many times does n go into this? It's just habits that I can't lose. Sorry about that. All right, how many times does n, once again, we're just looking at the n. How many times does n go into negative 6n? That's negative 6 times. So n times negative 6 is negative 6n. Negative 4 times negative 6 is positive 24, and we subtract these two. Negative 6n minus negative 6n is 0. 24 minus 24 is 0, and your result is 0. So this result here is the remainder. Like I said, we're going to have remainders of 0 in these instances, and I hope that you are good and okay with that. So here's what I want to write in factored form now afterward, if this is okay. So 10n squared minus 46n plus 24. We know that when we divide it by n minus 4, we get 10n minus 6. That also means when we multiply n minus 4 and 10n minus 6 together, these two together here, we do get that result. So I'm just stating that this equals this times this. Here's a version of the factored form. But like I promised, guys, what I get as a quotient will also almost always, I can't remember because I created this a couple days ago, it'll almost always be factorable. That means 10n minus 6 here, there's something I can factor here. If you notice, there's a common factor of 2. I can factor a 2 out of both of those terms there, and I'm left with 5n minus 3, and that's n minus 4 as well. And you know what? If you did some factoring stuff with me in the past in quadratics, we could have figured out that that's what this factored into. That would have been good and great. Okay, my phone buzzed a couple times. I coach softball, and we've just had a wave of messages between players and coaches there. So it might keep going off if you hear a little vibration. I apologize. Anyway, I think, so I don't know what my conversation went to, so I'm just going to state that, yeah, you know, this thing was factorable from the jump. It might be something where we can say, hey, we could have factored this on our own, right? Why do we have to use division to figure this thing out if this is what it becomes? We've done this before, and, you know, you're not wrong. But this was a quadratic, and we've factored quadratics before. Can you factor this? I'll tell you what, I can't even factor that. I don't know how to. I can say if I know one of the factors, which there's a way to learn factors using what's called the rational root theorem. If I find out one of the factors of this, I can divide that factor out. And then if I divide the factor out, possibly I present myself with something that is then factorable to how I know how to do it. So I'm going to move myself over here, and let's go ahead and take a look at this one here. Let's go to r to the 4th plus r cubed plus 3r squared plus 5r minus 10. And let's divide that by r plus 2. So as the same thing as last time, guys, we're really only going to look at the leading term here into each leading term. How many times does r go into r to the 4th? It goes in r cubed times, and r times r cubed is r to the 4th, as expected. You know, once again, we're looking for this to cancel, and 2 times r cubed is 2r cubed. And as we subtract, remember without me writing the symbol, r to the 4th minus r to the 4th is 0, r cubed minus 2r cubed is negative 1r cubed. So we bring everything else down here, the 3r squared, the 5r, and the minus 10, because technically these are subtracting 0 with these as well. So let's look at r plus 2 with that once again. R goes into negative r cubed, negative r squared times. And once again, you know you're doing it right when the next thing that you have here cancels, like r times negative r squared is negative r cubed. These should be identical, because if they're not, something's kind of screwy. We want to go down another degree each time. So you know that you're putting in the right number there when you get this back out. 2 times negative r squared is negative 2r squared. And so far, we've only seen things that, line up immediately right here. You want to make sure you line up like terms when you do that. R cubed, negative r cubed minus negative r cubed is 0. 3r squared minus negative 2r squared is 3r squared plus 2r squared, which is 5r squared. So we got 5r squared plus 5r minus 10. Let's keep going. R goes into 5r squared 5r times. And, like I said, guys, this will get pretty repetitious here. Maybe you know what's going on, maybe not. R times 5r is 5r squared. How are the Braves doing? Beautifully, 2-0. 2 times 5r is 10r. And we subtract on down. 5r minus 10r is negative 5r. And there's a negative 10 to bring down. And this is looking very pretty. R goes into negative 5r, negative 5 times. And we have a negative 5r. 2 times negative 5 is negative 10. And as before, the remainder turns into 0, which is great. So that is the quotient. That is the quotient. Now, it looks like I didn't provide myself very much room with what I expected to do here. So let's kind of block this off here. And let me write out that this whole thing, this r to the 4th, etc., that factors down to this times this, right? R plus 2 times r cubed minus r squared plus 5r minus 5. So r plus 2 times r cubed minus r squared plus 5r minus 5. Now again, you know I wouldn't give you a problem like this unless I felt like I want to play with some sort of factorization here. And I don't know if you recognize factoring by grouping cubic quadrinomial for what it is, but yeah, you can guarantee that this thing can factor down a heck of a lot more. Let's shift this thing over here. Give me a moment. So, whoa, look at that. All right, so move that thing over. So this thing factors into, remember that equals that, but this rightmost thing right here from r plus 2, this guy I need to keep factoring in such a way that I'm going to factor by grouping. So I'm going to factor common factor out of these two here. So there's an r squared that can factor out and left r minus 1. And here I can factor out a 5, and I'm left with r minus 1 right there. And so then that guy factors into, I can factor the r squared plus 5 and r minus 1. And you know what? My OCD is kicking in here. I want the r squared plus 5 first. R squared plus 5 times r plus 2 times r minus 1. And we are factored down there, all hunky-dory and such. So yeah, we could factor by grouping that cubic right there, right? I knew how to do that one in factoring that one down. The r minus 1 was a common factor in both of those, and that's what we're left with. So this times this times this equals that. Ain't that interesting now? All right. So there are the first two problems. And by the way, I do keep hearing my phone go off. I feel like it's something I should keep checking as there it goes again. All right. Number 3. 18n squared plus 87n plus 60. So once again, it looks like one of those quadratics again. It's just now differently with the 6n. I wanted to make sure if there's a larger number that we kind of save it a little bit for later. So here's later. I have 18n squared plus 87n plus 60. And we divide that by 6n plus 5. All right. So now we got to see how many times 6n goes into 18n squared. Now it's not just, now we got to do 6 times what is 18, which isn't a big deal, but just, you got to make sure you focus on that. And that's going to be 3n. So 6n times 3n is indeed 18n squared. 5 times 3n is 15n. I seem to remember when I redid this worksheet, I turned all these into x's instead of these variables. So I kind of feel bad that they're back to these variables. I must have an old version of this file. I apologize for that. Anyway, subtracting here. Let me darken this, or let me just brighten the color a little bit here. Subtracting these right here, that's 0 and 87n minus 15n is 72n. That looks better. 72n plus 60. How many times does 6n plus 5 go into that? 6 goes into 72 12 times. So plus 12. Give me one moment. And then the n, 6n. Yep, there we go. So 6n times 12 is 72n. 5 times 12 is 60. And as expected, we should be getting a 0 remainder there. So 3n plus 12 is the end result of that guy. So this thing here, I'll just point to it. This thing factors down into 6n plus 5 times 3n plus 12. Now 3n plus 12, that is a common factor of 3. So if I factor the 3 out of there, I'll keep the 6n plus 5 up front. But I have now n plus 4, right? I factored a 3 out of here. I spilled it out there. But the n plus 4 is what remains with that bit there. And again, what I'm writing, the answer is this as far as quotient goes. I want you to write in factored form, though, what the OG dividend is there, at least as far as what I'm having my students practice, making sure we're still getting all of that factoring in. Let's never leave that. Let's always assume that there's something further that we're doing, right? That's not gone. All right, 14a cubed plus 41a squared minus 50a minus 77 divided by 2a plus 7. Here we go. What color combination would I like to do here? 14a cubed plus 41a squared minus 50a minus 77 over, or divided by 2a plus 7. Okay. How many times does 2a go into 14a cubed? 7a squared times, of course. 2 times 7 is 14. A times a squared is a cubed. Looks like that's panning out just fine. 7 times 7a squared is 49. A squared. Here's one of the things for this long division that I didn't mention, guys, and it's, boy, you don't want to mess up. I don't know if this is obvious to you, but you screw up one small thing, a single little thing, even such as, I'm saying that I'm subtracting these, which I am. If you accidentally add these once when you should be subtracting, you messed up your whole problem. You got to redo, and you might not even know whether or not you're correct. So one way that I think my students will know they're correct is if they get a remainder of 0. Then they'll kind of know that something didn't go wrong, because I'm just, I'm sticking with remainders of 0 for now. 41 minus 49 is negative 8. So, I don't want to mess up either. And if I do, I guess you won't know about it unless it's really right at the end. Because otherwise, I'd want to edit it out. Not for my sake, just not to not waste your time. All right, so I subtracted those. I got negative 8a squared and bring those down. 2a times negative 8a squared is negative 4a. 2a times negative 4a is negative 8a squared. And 7 times negative 4a is negative 28a. So subtract and cancel. Minus a negative. So negative 50a minus negative 28a is negative 58 plus 28a, which is negative 22a. And then negative 77 is right there. All right, 2a plus 7. How many times does 2a go to negative 22a? Negative 11 times, of course. 2a times 11, negative 11 is negative 22a. So, I really am just doing the problems at this stage. A little drill and kill with that. I'm really talking how I'm going through the problem there. There's a remainder of 0, and there's your final result. Now, one more time, guys, and I can't guarantee, again, I can't remember what I did when making this set, but if I gave you this here, then it's likely that it's factorable. This isn't something like a common factor. 2a plus 7 times 7a squared minus 4a minus 11. One more time. This factors down to that. But 7a squared minus 4a minus 11. Let's check that one out right here. 2a plus 7 is right there. Okay, let's see. 7a and a. Let's try this. 11. Well, let me put a plus and a minus here. 11 comes from some form of 11 and 1, right? So if I put the 11 and the 1 here, I wouldn't put an 11 here. That's 77. This is negative 7 plus 11, which is positive 4. We need a negative 4, so I'm going to swap these two right here. That'll be negative 7, minus 11 and plus 1 like that. So apparently that's what it factors down to. And again, if my OCD kicks in a little bit, I always like to put larger numbers first. I really apologize for putting stuff like this. You might be wondering why I'm doing it. Because it looks better to me. And that's the only answer that I have for you. So this times this times this equals that big guy right there. Never stop practicing factoring. All right, let's keep moving forward. Numbers 5 and 6, the last two that I'm going to use long division on. 2x to the fourth plus Let's go ahead and do this. Let's go back to blue. 2x to the fourth plus 3x cubed plus 9x squared plus 12x plus 4. Now this problem is a little bit different here because this time we are dividing. This time we are dividing by x squared plus 4. There's really nothing different in what you're going to do. You have to be careful on how to write certain things. You have to notice it's an x squared. And furthermore, what I want to emphasize is you can only do something of this nature in a straight up dividing a quadratic immediately with long division. You couldn't do it with synthetic division. And we'll get in synthetic division. Okay. How many times does x squared go into 2x to the fourth? That is 2x squared times. X squared times 2x squared is 2x to the fourth. Now, here's something you got to be careful with. 4 times 2x squared is 8x squared. Do I put an 8x squared here? I wouldn't. These don't combine. I would put it, and you know what? I want to change color here. I would put it with the x squared term, right? We're all about combining like terms here. So let's make sure that we combine like terms with that. There we go. So we want to combine like terms there, which means that this 3x cubed still exists in this thing when we end up doing the subtraction, right? So we subtract those out, and we get a 3x cubed coming down here. 9x squared minus 8x squared is 1x squared, and then plus 12x plus 4. So yeah, you know, you just got to be careful where you put that thing. You want to make sure you combine like terms when you do it, and that's what makes this problem a little bit different to start with. X squared goes into 3x cubed, 3x times. X squared times 3x is 3x cubed as expected. And one more time with this thing, maybe not one more time, but 4 times 3x is 12x. That's going to go right here. And we subtract these guys out right here. And 12x minus 12x is 0. We have x squared plus 4. Hey, you know, I got an x squared plus 4 over here as well. How many times does x squared go into x squared? 1 time, as you can imagine. We got x squared there. 4 times 1 is 4. And x squared plus 4 is all gone. Remainder of 0. So we get 2x squared plus 3x plus 1. All right, so what am I going to do with that? Well, you know. I'm going to take this right here and say that, and I'm not going to rewrite it. I'm just going to kind of draw an arrow down and say, hey, you know this thing right here? You know an equivalent to it? The divisor times the quotient. So this x squared plus 4 times 2x squared plus 3x plus 1. But I got a quotient, and I didn't try factoring this quotient out at all. Let's see if we can do something with that. X squared plus 4 is right here. And here, oh boy, let's try that again. Same thing. Here I get 2x times x if it's factorable. Let's go ahead and give it a shot. A little plus plus going on. 1 is 1 and 1, so let's see if that works. 2 plus 1 is 3. Yep, that seems to work out. So there's my final result. X squared plus 4 times 2x plus 1 times x plus 1. And that's the final factorization of that above OG expression. As we factored an x squared plus 4 out, as we divided the x squared plus 4 out, if you will. All right, number 6. Last one on long division here, as we're almost a half hour in. I was wondering with this video beforehand, I was thinking, will this take a long time? Will it be a little time? It looks like it's going to take a long time. I was wondering if this is something we could do fast. I could kind of do these fast. There's just an explanation. There's just a lot of writing, and obviously I'm doing a lot of explaining with it. All right, here we go. 6x to the fourth minus 30x squared plus 24 divided by 2x squared minus 8. Now, I'm going to let you know right off the bat. There's something I didn't do here. And it's something I don't do. There's something I didn't do that you might have to be careful with depending on the problem. And I'm not going to speak on it unless it shows up here or until synthetic division. But I will speak on it after the problem, regardless. All right, 2x squared goes in 6x to the fourth, 3x squared times. You know, I don't think it's affected by this problem here. 2x squared times 3x squared should be that 6x to the fourth. Indeed it is. Negative 8 times 3x squared is negative... Oh, sorry, this is an x squared right here. I just must miss it with the undo button. Negative 8 times 3x squared is negative 24x squared right there. And I lined it up with an x squared. And you know what? That's kind of so. Okay, so I'll just bring it up right now. What I was going to mention is there is no x cubed term here. There is no x term here. They were missing. And it's possible that as you multiply some of the other lower degrees within here, that you end up getting an x cubed and an x and something like that we have to subtract with. So without those terms there, it's like if there's no in between, you know, what do you do when there's a space? You just make sure you don't combine anything that shouldn't combine. That's all I just wanted to mention. Anyway, so these will cancel right here, and negative 30x squared minus negative 24x squared is negative 6x squared, and I have plus 24 right there. And then let's go ahead and divide again. 2x squared minus 8, and 2x squared goes to negative 6x squared negative 3 times, and 2x squared times negative 3 is negative 6x squared. Negative 8 times negative 3 is positive 24, and we end up getting 0. So this factors 2, and I'm seeing a couple things with this that we're going to have to potentially play with. This thing factors down to... This thing here factors down to. By the way, this is something we would have been able to factor together. It looks like one of those quadratics, higher polynomial in quadratic form. We've done those before as well. I'm sure we could have played with this. So this factors into 2x squared minus 8 times 3x squared minus 3. Now, I see common factors in both quantities here, including the one that we divided out to begin with. Ever notice how there was a common factor of 2 this whole time? I'm not saying you should have done it earlier. I want you to stick with practicing that. I'm going to factor the 2 out of there, and I get x squared minus 4. You know what? This one has a 3 that I can factor out here as well, and I get x squared minus 1. Oh, this is full of fun right here. Check this out. So 2 times 3 is 6, as we factored both of those out. And x squared minus 4 in and of itself is a difference of 2 squares, which factors into x plus 2 times x minus 2. And x squared minus 1 is a difference of 2 squares, and that factors into x plus 1 times x minus 1. This whole thing right here, that entire thing right there was this. All that multiplies to make this right there. Fun factoring, right? And that's why I'm having them be factorable. And I'm trying to think if the backside of synthetic division have them all factorable. Now suddenly I don't know. I remember I wanted to make sure that the front was. All right, guys. I can't guarantee. I can imagine not all of them on the back will be factorable. There's kind of a reason why I'll mention later. Okay, guys. So that was the front side. That was long division. Now synthetic division. Synthetic division is this different animal. It is. Let me explain it slightly. Not the how to do it. I'm going to show you how to do it. But let me explain when you can use it here. Synthetic division. It is a clean form of polynomial division. And I don't know if I can get all the bells and whistles as far as explaining why what it does is meant to make things cleaner the way it is. I'll try, but since we're not doing the same problems as long division, I don't think I can guarantee what I'm going to talk about. But it's meant to make things kind of clean and streamlined, provided that you know when to use it and how to use it. First of all, you can only use synthetic division to divide by linear factors. It needs to divide by some sort of x to the first power thing. Not a quadratic like the last couple were x squared. You can't do it with that. You can do one at a time. If you know how to factor that quadratic, you can factor a linear part and another linear part, one and then the other. And I think one of these problems we're going to be doing that. That's number one. Number two, the linear factor needs to have a 1x kind of coefficient. It can't have a 2x or a 3x or whatever. So you're going to have to factor that out in some sort of way. You have to pull that out. And that's what I'm going to make sure to do with these problems as well. Synthetic division doesn't show variables on it. So there are things you're going to have to know and assume to do with it, because it assumes that it's going to do everything that we did in long division, and it assumes you have a linear factor and everything like that. It's kind of weird regarding that, but the magic in it is we make it clean for you if you know that you can only do it the right way. I know I'm over speaking on it here. Let's go ahead, and I'm prepping it so much here. Here's what we're going to do. We are going to find the 0 of the factor x minus 3, the thing that we're dividing by. Meaning, if x minus 3 equals 0, what is the value of x? The value of x is 3. 3, basically the opposite of negative 3 here. 3 is the 0, as some people call it the root. 3 is the root. 3 is going to sit up in a corner right here, in this nice little box. 3 is going to sit right there, okay? That root. There's a reason why it's that number. I don't know if I can explain it based on what we're going to do. We'll see if I can. I'm now going to take every term here in the OG dividend, and I'm going to write out the coefficients and the constant term out here, like 8, negative 12, negative 30, negative 9, and negative 27. Now, important aspects to this, and we are going to run into them. You must place 0 coefficient placeholders if you're missing a degree. So we went from the 4th degree to the 3rd degree to the 2nd degree to the 1st degree to the 0 degree. We weren't missing a degree. We didn't skip any. If we skip any, we have to put a 0 placeholder. Everything in this, if you remove variables with this, it's assuming that you're going to do all this properly. Now, there's another row of numbers that will end up being placed here. I'm going to skip that for a moment, and I'm going to draw a nice large line here. And what we're going to do with every column, what we're going to do with every column here is we are going to be adding the number on top with a number on bottom if it exists. Right now, and this is all weird saying for the first time, 8, I'm just going to bring the 8 down. 8 is not going to add with anything, and I'm just going to place an 8 right here. Here's what we're going to do in each step. This 3, this guy in the box, in kind of a corner box here, this root is going to multiply with values in the bottom. And what we're going to do is multiply that and bring it up here. So I'm going to multiply that by 3. 8 times 3 is 24. Now I'm going to do is I'm going to add these two values and get a number here. I'm going to add them, not subtract. I'm going to add them. Negative 12 plus 24 is 12. Now 12 is going to multiply by that 3. And 12 times 3 is 36. And then I have negative 30 plus 36, and I'm going to get 6. And 6 is going to multiply by 3. And I get 18. And then negative 9 plus 18 is 9. And then 9 is going to multiply by 3 and come up here, and I get 27. And negative 27 plus 27 is 0. Okay, so we have these numbers. What do we do with them? If you recall, and if this kind of helps out a little bit, this was a quartic polynomial, and then we divided by a linear. We did something x to the 4th divided by something x. The final result of this thing should be something x cubed. So this 8 is going to represent here the x cubed term. This thing will become 8x cubed. This 12 is going to represent the x squared term, plus 12x squared. This 6 is going to represent the linear term x. The 9 is going to 6x. The 9 is going to represent the constant 9, and 0 represents the remainder. So here's what happens. We started with a quartic cubic quadratic linear constant, and now it's a cubic quadratic linear constant remainder. Everything went down 1 degree because this thing assumes, understands, and imagines that you had a linear factor that we divided by here. Okay. Now, why did we choose positive 3 instead of this negative 3 here when it comes to this? Because instead of subtracting here, we're now adding, right? Instead of subtracting, we're now adding. So we had to switch this sign here. If you imagine, before we'd multiply negative 3 by numbers and then we'd subtract them. Now that we switched its sign, we're now going to be adding them. Kind of strange. And I know I'm not getting into the full effect of what this thing is right here, but this is the quotient. Whoopsie, I can't do that. Let's split that up. This is the quotient to... Why isn't this squared? I'm sorry, I'm trying to drag this all over. This is the quotient to this divided by that, which means this guy right here, of course, equals, this guy right here equals x minus 3 times 8x cubed plus 12x squared plus 6x plus 9. And ho, 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 we're not done. You didn't think I wasn't going to go without trying to factor this out, did you? Let's try and factor this guy. By grouping here, we have 4x squared can factor out of there, and you're left with 2x plus 3. A 3 can factor out of here, and you're left with 2x plus 3. Kind of running out of room. That's kind of unfortunate. By the way, we still have this x minus 3 here. And therefore, this thing all factors down to x minus 3 times 4x squared plus 3 times 2x plus 3. And it looks like there's nothing else I can factor, but of course if I could rewrite this, I'd put the 4x squared plus 3 first, I'd put the 2x plus 3 second, and I'd put the x minus 3 last, because that is just what I do. So that's the final result for number 7. I can bring some of that stuff. So synthetic division, guys, there's kind of a visual gimmick. I can't remember. There's kind of a visual gimmick to it. There are very many reasons for it to work. It's really nice and clean. It works fast when you know what you're doing with it there. You just got to be careful with what's going on. I'm probably not going to draw all these little arrows here next time. Just understand that number's going to multiply by 3, and we write the next number up there. And then we add. This part goes really fast. And this is the part where you can circumvent writing all this other stuff right here as you work down. I know that all the variable stuff can confuse you. You just got to make sure you know what you're doing with it. So let's jump on to number 8 here. X to the 4th minus 5x cubed minus 24x squared divided by x plus 3. Now x plus 3, that means that the root here, if x plus 3 equals 0, the root, if I subtract 3 from both sides, it will be a negative 3. So in synthetic division here, everything's going to multiply by that negative 3 when we add down the lists. Now I have an x to the 4th term. Its coefficient is 1. 1x to the 4th. Negative 5x cubed. Negative 24x squared. We need a linear. 0x, and a constant, 0. We need to go all the way down to the constant there as we divide. Well, divide. Synthetic division is a little bit different. I don't know if you know what synthetic means. I believe synthetic means fake. We're not really showing any division here anymore. Everything is just working out the way that it should. There's a lot more as to why this works the way it does. It's kind of fancy how it does work as far as everything else. One thing I guess I can mention is, you know, in long division, every time that I'm saying like how this cancels out here, or this cancels out here, stuff like that, we're circumventing this part completely. This part isn't even considered in the synthetic division. It's being completely left out, which I guess is part of the niceness of it there. So whoever created this, I guess good on you, but it might feel like a little bit of a magic trick, but there's reason for it to work, so you just got to make sure you do it right. All right, let's bring the 1 down right here. 1 times negative 3 is negative 3. Negative 5 plus negative 3 is negative 8. Multiply that by negative 3, you get 24. Negative 24 plus 24 is 0, and you get 0 here, and 0, and 0, and 0. And I'm mentioning these here just to make sure we know what's going to be written where. So if this is the remainder right here, then this is the constant, the linear, the quadratic, and the cubic. This is going to be a 1x cubed minus 8x squared. That's an x cubed minus 8x squared plus 0x plus 0, right? So that's what that thing divides down to right there. Now, of course, it's this thing that we were talking about right here. It's this thing we were talking about right here. This thing equals the 8x cubed minus 8x squared times the x plus 3. X plus 3. Now you can see that this thing totally will factor more here. Hold on. Where was my other purple? We can leave the purple that I was working with here. All right, so this thing has a common factor of x squared, and you have an x minus 8 that can factor out there, and we have an x plus 3. I almost feel like I was hoping for this to be a difference of 2 cubes when I factored, so I don't know. I guess it's not. That's okay. Okay, here. Having fun? We got 4 more to do. We have x to the 4th minus x cubed minus x plus 1 over x minus 1. Divided by x minus 1. Heck of a lot of 1s there. In fact, my root for this thing is also going to be a 1, a positive 1, right? Not a negative 1 here. So let's do synthetic division again. 1x to the 4th minus 1x cubed. Where's my x squared term? If it's missing, that means it's plus 0x squared. And you need, here's the thing, you need to put this placeholder 0 there. 0x squared. Minus 1x plus 1. A lot of 1s and 0s and stuff like that. So this thing's going to be pretty clean when we work it down. Bring this 1 down, multiply it by 1, you get 1. Negative 1 plus 1 is 0. 0 times 1 is 0. 0 plus 0 is 0. 0 times 1 is 0. Negative 1 plus 0 is negative 1. Negative 1 times 1 is negative 1. 1 plus negative 1 is 0. Okay, so this thing now, it leaves us with, again, this is the remainder right here. That's the remainder right there. And this is the constant. There's plus 0x squared plus x cubed. So it's x cubed minus 1. Remember, this was an x to the 4th. So this is now the cubic, quadratic, linear, constant, and then remainder. So that factors down to x cubed minus 1. I think I'm looking at, hopefully you know what we're looking at here, a difference of 2 cubes here. So this guy here factors down to x cubed minus 1 times x minus 1. So x cubed minus 1 in and of itself is x minus 1 times x squared plus x plus 1. That's the difference of two cubes thing going on. And this multiplies by x minus 1. This could be the final answer. I like the look of doing something with the x minus 1 times x minus 1, though. So let's kind of bring those together. I'll start with the x squared plus x minus 1, or plus 1, excuse me, and then multiply that by x minus 1 quantity squared, like that. That looks good. That looks good right there. Okay, so that's what that one factors down to. And again, you can see where we're playing with factors, sum and difference of two cubes, things like that. All right, number 10. Now, number 10's got a little bit of a different thing to it, just because, you know, right here it's 2n plus 8. And like I said, it needs to be a 1. So, you know, if you don't mind, I'm going to divide this instead by factor out the 2 with this n plus 8 here. Let's go ahead, guys. Let's divide these all by 2 first. Okay, so if I take these and divide these all by 2, then I can just, oh, sorry, not n plus 8, n plus 4. If I divide all of these by 2 here first, then I got rid of that portion there, which is nice. Divide 16n squared by 2, you get 8n squared. Divide 60n by 2, you get 30n. Divide negative 16 by 2, you get negative 8. So now we can take this and divide that just by n plus 4. Again, you need it to be a 1n because this thing's assuming the root for a linear factor with a 1 coefficient. Otherwise, this thing can't be the negative 4 that we want it to be. It's not going to work the way that we want it to unless we work that 2 out. Okay, so now we're going to work synthetic division with this right here. So negative 4 is going to be the root, or the 0 there, where we line up in 8 for n squared, a 30 for the n, and a negative 8 for the constant. And let's go to work. Bring the 8 down here. Negative 4 times 8 is negative 32. 30 plus negative 32 is negative 2. Negative 4 times negative 2 is 8. Negative 8 plus 8 is 0, as expected. That is the remainder, of course. And this is, goes from a quadratic to a linear. Let me make sure I've been doing the variables correctly here. X's, X's. Okay, all these were X's here. So now here's an n. So this is the linear. This is 8n, and then minus 2. So, of course, let's keep factoring this thing down. This thing factored down to. Now remember, there was a 2n plus 8 to begin with. I'm starting with the original thing, and 2n plus 8 was one of my factors, alongside, of course, the 8n minus 2. So 2n plus 8 times 8n minus 2. Common factors, let's get them. You know what, maybe I did make sure all these things factored out. I can factor a 2 out of this one, and I get 4n minus 1. And I can factor a 2 out of here, and I have an n plus 4, right? Make sure I didn't mess that up. 2 times 2 is 4. Sorry about this. Plus 4. 2 times 2 is 4. So I get 4 times 4n minus 1 times n plus 4. And, you know, it's one of those things we probably could have figured out and factored that one out on our own. All right, number 11. Now, I'm just going to let you know right off the bat. If you notice here, guys, we are looking at a sum of two cubes on the top. Just so you know here, that factors to x plus 3 times x squared minus 3x plus 9. Now, we're about to divide this by x plus 3. So you know what our final answer is going to be? Our final answer better be x squared minus 3x plus 9. We're going to see if we can divide a sum of two cubes by the linear factor that exists with it, and let's see if we get x squared minus 3x plus 9 when we divide this. We're going to use synthetic division, though. So let's do synthetic division. Negative 3 is the 0 for the divisor here, so negative 3, or for the factor. And I got a 1x cubed plus 0x squared plus 0x plus 27. Again, put placeholder values for each of those. It needs to be so we know what degree each of those are referencing. So here we go. Bring the 1 down. 1 times negative 3 is negative 3. 0 minus 3 is negative 3. Negative 3 times negative 3 is 9. 0 plus 9 is 9. 9 times negative 3 is negative 27. 27 minus 27 is 0. There's our remainder. And we are left with these right here. This was the cubic. This is now a quadratic. That is x squared minus 3x plus 9. Hey, we expected that. And you know what we're about to write right now? The result of what x cubed. And you know what? Just for good measure, I'm going to go ahead and write x cubed plus 27 down here as well. X cubed plus 27. You know what it factors into? It factors into x plus 3 times x squared minus 3x plus 9. And this is not further factorable. That is the result. That is the result of this sum of two cubes. Ladies and gentlemen, outside of distributing and showing that the things cancel, we've officially divided it by its other factor to show that indeed that's what it turns into. That's nice. I like looking at that. And you know what? This is just for this particular sum of two cubes. I'd rather do a cubed plus b cubed divided by a plus b and do synthetic division on that. That's a little more fun. All right, and finally, last problem here, number 12. And this is also something that's in the this is in the difference of two cubes category here, if you know what you're doing with them. But this is but there's more to be had here. This is a difference of two cubes divided by a difference of two squares. Isn't that something? So x to the 6th minus 64 divided by x squared minus 4. Now this one's a little tough for synthetic division because you cannot use a quadratic in your dividing. So you know what we're going to have to do here really is I'm going to have to factor the denominator. I know the numerator can be factored as well, but let's treat it as raw as we can, or as raw as we're allowed to be. X squared minus 4 is x plus 2 times x minus 2. So you know what we're going to have to do here, guys? So we're going to have to divide one at a time. We're going to have to divide one at a time. First, I'm going to divide this by x plus 2. I'm going to get something that remains, and then I have to take all that's left there, and then I'm going to divide that by x minus 2. Or we could, not in this thing, but in a general sense, or you could use long division. Long division would be much preferred for a problem like this one, you know. Anyway, if I'm going to divide by x plus 2, then negative 2 will be my root. Negative 2 will be my root. Right, so that one. Now, x to the 6th, oh gosh, 1x to the 6th plus 0x to the 5th plus 0x to the 4th plus 0x cubed plus 0x squared plus 0x minus 64. Woo, that's a lot of things there. Here we go. Bring down the 1 times negative 2 is negative 2. Bring it down. We got a minus 2 times negative 2 is 4. Bring it down. When I say bring it down, I'm doing 0 plus 4. 0 plus 4 is 4. Times negative 2 is negative 8. Bring it down is negative 8. Times negative 2 is 16. Bring it down is 16. Times negative 2 is negative 32. Bring it down. Negative 32 times negative 2 is 64. Add those together, we get 0. 0 being the remainder. I forgot how they do this, if they box it or something. I can't remember what they do. I haven't done long division, synthetic division in a long time, guys. I know how to do it. I just don't know how they like to write that portion there. Obviously, I know how to do it. We just did a bunch of problems here. So this was an x to the 6th, yeah? Well, now it's an x to the 5th. This is 1x to the 5th minus 2x to the 4th plus 4x cubed minus 8x squared plus 16x minus 32. And now, listen, we divided this by x plus 2. Now let's divide this result here by x minus 2. So the last one that we have, let's now divide it by x minus 2 and kind of see what we can get there. And I mean, this turned into a massive polynomial in doing that. Let's sure hope this thing cleans up the way it does. And you know what? You could factor this by grouping if you know what you're doing there. You can totally factor this thing by grouping. But of course, let's just keep going. All right, so x minus 2, that means 2 is the factor there. 2 is the factor. And we're going to have 1x to the 5th minus 2x to the 4th plus 4x cubed minus 8x squared plus 16x minus 32. And let's go to town on that. So bring the 1 down, times 2 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. And here we got a 4. 4 plus 0 is 4. Times that is 8. Negative 8 plus 8 is 0. 0 times 2 is 0. 16 plus 0 is 16. 16 times 2 is 32. Negative 32 plus 32 is 0. Remember, that's the remainder. So this was a, what, 5th power? So now this is a 4th power here. This is x to the 4th plus 4x squared plus 16. So the end result that we have, and there's more factoring to be had. The original, let's see, let me write it. X to the 6th minus 64. This equals this thing here times, what were our other factors? X plus 2 and x minus 2. It was really the x squared minus 4, but we already factored those together, right? So we already know that's there. Okay, let's continue factoring this one down here. If you can. Oh, you know what? You can't. Can you? 16 and 4x squared? No, you know what? You can't. I guess you're done there. I was hoping that this could have done something else as a special quartic there, but it looks like, you know what? It looks like that's it. It looks like there's not much more to do. All right, guys. So that'll be it for that factorization there. No two numbers multiply to make positive 16 and add to make positive 4, unless I made a mistake somewhere, but I don't think I did because I got a 0 remainder. And that's what I expect. Okay, guys, so that synthetic division is a little different animal in and of itself. The more that you practice it, the more you'll make sense as far as placeholders go. They go really fast with what you're doing, when you should do it and when you shouldn't is kind of an up to you kind of thing. And I don't know if I hit every problem type under the sun to do that. But that'll do it for this one, guys. This one's Mr. Robinson. Thank you so much for watching. And anything else that you see from me here will be a good old review on this stuff and probably on the transformation stuff that we did from last month. All right, guys, thank you so much for watching. Take care. I will see you in the next one.